Hello everyone, Dennis here. In this video, we are going to talk about Chapter 2, Kinematics. Kinematics is a study of motion, which later on we will talk about distance versus displacement, speed versus velocity, and acceleration.
This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us.
Distance versus displacement. So what is distance? Distance is the total length covered between 2 points. It is a scalar quantity, while for displacement, it is the straight line distance in a specific direction between an object and a specific point. We usually be referred to starting point. It is a vector quantity. The SI unit for distance and displacement is meters, symbol m. Let's look at this example. This car wants to travel from point P to point Q. If it takes path A, it will need to travel 7 kilometers. If it takes path B, it will travel 10 kilometers. The direct distance from point P to point Q is 5 kilometers. Now, let's look at path A. We'll say that the distance for path A is 7 kilometers. For path B, the distance is 10 kilometers. However, when we talk about displacement, both path A and path B, they are 5 kilometers. Now, let's look at the difference between speed and velocity. The speed is the rate of change of distance, which means distance changes over a period of time. Speed is the distance over time. It is a scalar quantity. For velocity, it is the rate of change of displacement, which means displacement changes over a period of time. The formula for velocity is displacement over time. It is a vector quantity. The SI unit for speed and velocity is meters per second. Symbol is m/s or ms to the power of -1. What is uniform speed or constant speed? The speed is constant or does not change throughout the whole journey. So the formula for speed is distance over time. For non-uniform or non-constant speed, we determine average speed. Average speed is the total distance traveled over total time taken. When the speed of an object is 0, we can say that it is at rest, stationary, or does not move. So let's look at an example. George drives a car from town A to town B at an average speed of 80 kilometers per hour. It is known that the distance between the two towns is 180 kilometers. In the next day, George drives back from town B to town A at an average speed of 90 kilometers per hour. Calculate the average speed of the car for the whole journey. So you can pause the video and take some time to do the calculation. Okay, now let's look at the solution. We know that speed is distance over time. Time is distance per speed. So for this case, time taken from town A to town B is 180 divided by 80, which is 2.25 hours. Time taken from town B to town A is 180 divided by 90, which is 2 hours. Hence, we can calculate the average speed, which is total distance over total time. The distance is 180 plus 180 kilometers. The time is 2.25 plus 2 hours. Then we will get the answer is 84.7 kilometers per hour, which is round off to 3 significant figures. Acceleration. Acceleration is the rate of change of velocity. It is a vector quantity. The SI unit for acceleration is meters/s to the power of 2 or meter second to the power of -2. The general formula for acceleration is change in velocity over time taken. So A is delta V over delta T, and A is V minus U over delta T, where A is acceleration, delta V is the change in velocity, U is initial velocity, and V is final velocity. And delta V is the change in time. Deceleration is used to describe an object is moving at decreasing velocity. It can be interpreted as a negative acceleration. For example, when the brake applied on a car, it decelerates at 5 meters per second squared, or its acceleration is -5 meters per second squared. Now, let's look at the example. A particle is moving forward at a speed of 6 meters per second. It takes 5 seconds to stop and reverse at 4 meters per second. So this diagram illustrates the condition: 6 meters per second moving forward, and reverse. At the end, you get 4 meters per second. Taking the forward motion as positive, calculate the change in speed, the change in velocity, and the acceleration of the particle during the 5 seconds when it stops and reverse. So you can pause the video and try to answer the question. Okay, now let's look at the solution. The change in speed is final speed minus initial speed. For this case, the final speed is 4 and the initial speed is 6. Then the answer is -2 meters per second. For the change in velocity, it is the final velocity minus initial velocity. So the final velocity is -4 because it is in opposite direction. So -6 as the initial velocity, and the answer is -10 meters per second. Now the acceleration, we use this formula, A equals to V minus U over delta T. For this case, we have found the answer for V minus U, which is -10. Then the time is 5 seconds, and the acceleration is -2 meters per second squared. Now, let's look at distance time graph. So distance time graph always is a non-decreasing graph, regardless of whether the object changes direction. Recall that the definition of distance, it is the total length covered throughout the whole journey. The gradient of the distance time graph at any point is equivalent to the rate of change of distance, which is speed. So when the gradient is constant, or is a straight line, the object moves at constant speed. When the gradient curves up, or we say it is a smiley face, the gradient increases, it means the speed increases as well. When the gradient curves down, or we call it a sad face, the gradient decreases, it means the speed decreases. When the gradient is 0, or it is in horizontal line, the speed is 0. Object is at rest or stationary point. This slide shows the distance time graph. So this curve is a smiley face, or the gradient curves up. It means it is in increasing speed. This is a horizontal line, which means the gradient is 0 or speed is 0. So this is a straight line, or the gradient is linear. That means it is constant speed. So for this case, the gradient is linear and less steeper. so it is at lower constant speed. So this gradient curves down or a set phase, it is decreasing speed. Speed time graph. Speed time graph always is a non-negative graph regardless of whether the object changes direction. Recall that speed is a scalar quantity, does not have direction. Hence, negative speed does not give any meaning. When the speed is zero, the object is at rest. When the speed is positive, the object is moving. The gradient of speed time graph at any point is equivalent to the rate of change of the speed, which is acceleration. When the gradient is constant or a straight line, the object moves at constant acceleration. When the gradient curves up or a smiley face, the gradient increases, which means acceleration increases. When the gradient curves down or a sad face, the gradient decreases, which means acceleration decreases. When the gradient is zero or horizontal line, acceleration is zero. Object is at uniform or constant speed. The area under graph of a speed time graph gives the total distance traveled within the period of time bounded under the graph. This slide shows speed time graph. For this case, the negative gradient curves up, which is a smiley face. It means it is decreasing deceleration. This is the minimum point of a curve. The gradient is zero, which means acceleration is zero. This is positive gradient curves up, which is a smiley face, which means increasing acceleration. This is gradient is zero when it is a horizontal line, the speed is constant. This is positive gradient linear or straight line, which means constant acceleration. For this case, the line is less steeper and it is a positive gradient. It means it is lower constant acceleration. So positive gradient curves down or a set phase, which means it is decreasing acceleration. This is maximum point of a curve. The gradient is zero. That means acceleration is zero. This is negative gradient curves down, which is a set phase. It is an increasing deceleration. Negative gradient is linear or a straight line, which means the object moves at constant deceleration. And lastly, this is area under graph, which will give you the total distance traveled between T1 and T2. There are three important formulas from linear speed time graph that you need to remember. This slide is going to discuss about how we can get the formula. So look at this diagram. Let's say this is u, the initial speed, and this is v, the final speed. This is the total distance for the change of the speed. We know that acceleration is v minus u over t. Hence, when we make v the subject, so v will be equals to u plus at. So this is the first important formula. Next, this is the area under the graph, which will give you the total distance traveled s. And we know that this is a trapezium, so we just apply the trapezium formula and we'll get s equals to half bracket u plus v times t. When we make t the subject, it becomes t equals 2s over u plus v. Next, from the first formula, v is equal to u plus at. So we substitute the t into this formula and we expand. This is what we get. So from here, we can cancel the uv and Finally, it becomes v squared equals to u squared plus 2as. So this is the second formula. Now, look at this. V squared equals to u squared plus 2as, and v equals to u plus at. So we substitute this first formula into the second formula. It becomes u plus at squared equals to u squared plus 2as. When expand, it becomes u squared plus 2u at plus bracket at squared equals to u squared plus 2as. Then we can cancel the u squared, and we take out the a bracket 2u plus at squared equals 2as. And now we can cancel the a. So the s becomes 2ut plus at squared over 2, or s equals to ut plus half at squared. So this is the third formula that you need to remember. But do take note that these three formula only used when it is at constant acceleration. So for the first formula, there is no s. For the second formula, there is no t. For the third formula, there is no v. So what does it mean? It means that when you read the question, if they don't give you the total distance traveled, then you can use the first formula. If the question does not give you the time taken, then you can consider if you can use the second formula. If the question does not give you the final speed, you might consider to use the third formula. Acceleration of free fall. An object experiences free fall when its motion is under influence of gravity only. Usually, this can happen in vacuum. The only force acting on the object is its own weight, W equals to mg. All objects on Earth fall downwards at an acceleration of about 10 meters per second square due to gravitational pull force. This acceleration is called gravitational acceleration, g. Hence, g equals to 10 meters per second square. It is independent of the size, shape, and the mass of the object. Hence, a feather and a hammer, which fall from the rest at the same height, will reach the ground at the same time without air resistance. Any object that moves in air will experience a force called air resistance, which tends to slow down its motion. Air resistance is proportional to the contact surface area between the air and the object, the speed of the object. When the speed of a falling object increases, air resistance will increase as well. When air resistance equals to the weight of the falling object, net force is zero. Hence, the object reaches terminal velocity and stops accelerating. This slide will discuss how the air resistance changes will change the acceleration of a falling object. So this is a falling object with mass m. It has one downward force, which is its weight. And it experiences air resistance R when it falls down. So this is the resultant force. This graph shows the velocity time graph. So at the first few seconds, from 0 to t1, right, the air resistance is negligible. The resultant force is just the weight, and the acceleration is equal to g. When the object accelerates, its speed increases, hence the air resistance increases as well. So this is shown from t1 to t2. The air resistance increases. The resultant force will be mg minus r. Therefore, the acceleration will be less than g. When it reaches its terminal velocity at t equals to 2, Then the air resistance will be equals to the weight. The resultant force will be 0 and the acceleration will be 0 as well.
That's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write down in the comments. I would love to hear from you. Do you like this video? Please don't forget to like it and share it. Alternatively, you can also enroll this full revision course at Udemy. At Udemy, you can track your learning more effectively. Download my notes in printable PDF form. Take a summative quiz at the end of each chapter. Get your first-hand updated contents from me. Get quicker response from me, and many more. You can get all these benefits at a very affordable price. It is one-time payment, no recurring fees, no hidden costs. This saves you thousands of dollars on expensive tuition fees and revision crash courses. And most importantly, your precious time. Finally, you can do your revision anytime you like, anywhere you prefer. All is available within your fingertips. Check out the description below this video and click on the enrollment link to register the course at discounted price. Alright, until then, see you in the next video. Have a great day ahead.